Let's deal with binary acids first. Binary acids are acids that have hydrogen and something else. Hence the name binary acids. Binary means two. Bicycle has two wheels. Binary acids have hydrogen and one other type of element. Binary acid nomenclature goes as follows. It starts with the prefix hydro, and then we write the prefix of the other element followed by ic acid. This one here is going to be called hydrofluoric acid. This one will be called hydrochloric acid. And can you guess what this next one is? Hydrobromic acid. Now, if we have the name and we want to write the formula, we go, let's see, it's got hydrogen and iodine, and then we might look on the periodic table to find where iodine is so that we match up the correct number of hydrogens. Hydrogen is in the upper left, and you can almost think of it as +1. Iodine is element 53 in the halogen column, so it's going to get a charge of 1-. So, high. Similarly, hydrosulfuric, if we find sulfur on the periodic table right below oxygen, sulfur is number 16, and it's going to get a charge of 2-. That's how we know that we're going to need 2 H's to match up with each sulfur. So those are binary acids. Oxyacids are acids that contain hydrogen, oxygen, and one other thing. These are also called ternary acids, the prefix ter referring to 3. Primary structure, secondary structure, tertiary structure, ternary meaning 3. Hydrogen, oxygen, and one other one. An oxyacid or a ternary acid, those are synonyms. For oxyacids, the naming conventions are as follows. For the most common forms of the oxyanions, we write the prefix of the oxyanion followed by ic acid. Now, when I say here most common form, that refers to the polyatomic ions that I called most common in an earlier lesson. And those are the bromate ion, the chlorate ion, the iodate ion, the nitrate ion, carbonate, phosphate, and sulfate. Those are the most common forms. And you can see that in these first 3 examples, we have 3 of those most common anions. We have in this first example the bromate ion. In the second example, the chlorate ion. In the third example, the carbonate ion. So, for the most common forms, which is what we're going to have here, we're going to write the prefix of the oxyanion followed by ic acid. The oxyanion is the bromate ion, so the prefix of that would be brom, and then we say ic acid. For the next oxyanion, that's called the chlorate ion, so we need to write its prefix and say ic acid, chloric acid. Chloric acid. Not hydrochloric, because hydrochloric we only start the acid name with hydro if it's a binary acid, if it has hydrogen and only one other thing. In this third example, this is the carbonate ion, so the prefix would be carbonic acid. Similarly, sulfuric acid will contain the sulfate ion. And sulfate is SO4, 2-. So how many H's are we going to need to make a neutral compound? 2, H2SO4. Similarly, phosphoric acid, what's the most common oxyanion that goes with phosphoric acid? That would be the phosphate ion, PO4, 3-. So to give a neutral compound, we need 3 H's. That's what you do for the most common forms. If an oxyacid differs from the above by the number of oxygen atoms, then the name changes are as follows. Here we dealt with the most common forms. You say the prefix of the oxyanion and then you say ic acid. But if it's got one more oxygen than that, you say perchloric acid. If it has one fewer oxygen than the most common, you say us acid, and if it has two fewer, then you say hypo-us acid. Let's try some examples. Of these first four, which is the most common form of the oxyanion? And if you suggest that that would be this one, the second one down, you are correct. That is chloric acid. If our acid has one more H, according to the naming conventions at the top of the screen, that one's going to be called perchloric acid. If we're one oxygen short, chlorous acid, and if we're two oxygens short, hypochlorous acid. Let's try the next one. Phosphorus acid. Okay, what would the most common one be? Well, that would be phosphoric acid, which would be H3PO4. But it's not phosphoric, it's phosphorus. So instead of H3PO4, it's going to be H3PO3. It's always easiest to start at the root. What's the most common oxy acid? And that would be bromic acid, which is HBrO3. Bromus would be HBrO2. And hypobromous would be HBrO. And that's it. And lastly, persulfuric. I don't even know if this acid exists. We're just practicing using the naming rules. Sulfuric acid would have the sulfate ion, so that would be H2SO4. Persulfuric would have one more oxygen, so H2SO5.